Hi, welcome back to the video on deploying a machine learning model on Kubernetes. In the last video, what we did is we built a container of our Flask application. So basically, we had a Flask application, we built a descriptor file, a Docker file, and we gave instructions on the dependencies that need to be bundled within the Docker file, and also the command that needs to be executed when our Docker is deployed in a Kubernetes platform. So with the if you see on my screen, this is a Docker image that we built, and this image is in the Google Cloud registry, Google Container Registry repository. We are going to deploy this in a Kubernetes engine, in Google Kubernetes engine. As I said, the steps are pretty similar if you want to do on your local Kubernetes engine or any other cloud provider Kubernetes engine. Let me quickly go and search for Google Kubernetes. And what we are going to do is currently we will just a minute. Kubernetes. Yeah. So if it's currently we are not having any clusters. Yeah, there is no clusters. If you have a cluster, it will show over here. Currently, there's no clusters. That's why it is asking us to create a cluster. Now we can click here and create a cluster and also deploy a container. But what I will do is I will switch back to my command line utility and do it rather than doing it over console. Typically, when you are doing in a real world, maybe you want to build a DevOps pipeline or a HIAS pipeline that can build up the bring up the Kubernetes cluster, run the job, and maybe finally after you are done, maybe shut it down, right? So what I'm going to do is I'm going to do it over here. I already have the command copied. It has started building, but let me quickly explain it. So I just want to run it because it takes time to build the container. So what I'm doing is I'm using the gcloud container command. In the last video, I spoke about gcloud command, which is used to interact with your cluster, right? I'm using the gcloud container command and telling cluster create. So I'm telling to create cluster. I'm giving a name for the cluster over here, and then I'm telling to bring one node cluster. That's what it's going to do. And then I'm telling enable basic auth. You can give how much ever nodes you want, 2 or 3 or 4 nodes. I'm telling enable basic auth and issue the client certificate. So I'm asking the Google Cloud Platform to issue a client certificate. But in real world, maybe you need to have your own certificate and then attach to it. But just for quickly showing it, I'm doing it. And I'm telling setting my zone as US West 1B. That is the closest zone to where I am. If you want any zone that is closest to you, you can set that zone. And finally, I'm giving a scope object. The scope object is basically what I'm doing is I have enabled and Google Cloud logging in my previous video, right? I am telling it like in order for me the Google Cloud login to write into cloud logging service of Google, I need to give the scope, and the scope I'm telling like basically logging.write. I'm calling the Google APIs for cloud logging, and that's what I'm doing over here. So this is the line to start your cluster. While the cluster is starting, what I want to do is I also want to get started with the code specific to your Kubernetes, right? And rather descriptor specific to your Kubernetes. In the last video, we saw Flask app, Gunicorn, Docker file, right? Now we will be creating two different files. One is the deployment file, and second is the service file. So basically, for your deployment file, what happens? You have a container now, right? You have to deploy the container into an pod. That is a Kubernetes pod. That is the granular object for Kubernetes. Now, a pod is a group of one or more containers. You can have one container or you can have many container. In our case, we have only one container, which is our Flask application. And the multiple pods, multiple container within a pod shared the same storage network, right? And the specification how the container needs to be run, that's about a pod. So now what a deployment is, the deployment.yaml file, basically what it is responsible for keeping the pods up and running. So I have a pod now, I'm deploying a pod. I'm telling like I want one instance or two instance of the pod. Now the deployment is basically responsible, the specification is responsible. There's a deployment controller which is responsible for keeping the pods up and running. So if some pod goes down, it will restart the pod on a different system. That is about deployment. Now the second is service. The service is responsible for enabling network access to the pod. It can be one pod or a set of pod. And why do we need services? Basically, if you have multiple pods running, you don't want to manage the pod individually. Basically, you want to put a load balancer before the pod, right? And that's where this comes into play. Now we can use a deployment without a service, only a deployment object. We can use it without a service, but the only thing is, as you scale prod up and down, it becomes a overhead and a headache, and it becomes keeping track of the pod individually becomes difficult. So we need a service over here. So in the deployment, what we are doing is, basically we are telling its kind is deployment. It's just a YAML file. We are telling, giving a name. It's a flask app -gke, and I'm telling one replica. Now you can have two replica or three replica. If you have multiple nodes, you can tell go into each replica, go into multiple node. You can also have node selectors if you want to run on GPUs or something like that. There are multiple options available. I'm going with a very simple option here. Then I'm giving like basically my label for app as SA classifier, and this is what I'm going to give in the service as well, the SA classifier, for it to load balance if I have multiple prod replicas, if I have two or more, right? And then I'm telling my container. This container is what we created in our last video. I'm just giving a name of the container and giving an image, and this is the image that we have given in an this is where we stored our container, and we don't have any version, so it will be the latest container always. And I'm telling the container port is 8080. So basically, when the application, if you see my previous docker.yaml, right now, it ran till here. It installed all the dependencies. It installed the Python environment. It installed all the dependencies. Now, when we start a container on Kubernetes, it's going to run this command over here. All right, and this command, I need to basically, what I'm telling is that the port that I need to expose is basically 8080. That's what I'm telling over here. This is about deployment, right? The second is service. In the service is pretty similar. The only thing I'm doing is I'm telling my app name is SA classifier, and I am telling the type is load balancer. Okay, so the idea is this particular service that is there, that gets enabled during using a cloud provided load balancer. So for, if you're on AWS or GCP or Azure, they have their own load balancer. So the cloud provider takes care of getting the load balancer and attaching it to your application. And here what I'm telling, my target port is 8080, which I gave in the deployment, but the port that I want to connect is 80. So the HTTP, the default port is 80. So in this case, what I'm telling is my default port is 80, and I just want to connect my service using the 80 port. And internally, the service will take care of load balancing, routing it to the application, and everything. Right. So these are the two objects that we are going to now apply into the Kubernetes cluster. That's what we are going to do. So let me go back to my command line. If you see over here, basically the Google Kubernetes engine is running now. You can also go to the console. Now if you see, there was nothing. Now the console, you can see basically the flask app GKE is running, and you have one cluster, that is what we are given, one vCPU, and there's a 3.75 GB of memory, and you can accordingly tune your memory based on your application here. I just gave very basic configuration over here. So now going to the command prompt. Now, if you see, we have two objects, that is a deployment.yaml file and the service. This is a deployment.yaml file and the service.yaml file. Now, what I'm going to do is I'm going to apply this deployment.yaml file into our into the Kubernetes cluster. So for that, what I'm going to do is I'm going to use the kubectl command, which is the command line utility provided by Kubernetes, and I'm going to say like apply -f, which is the file name. I'm going to tell the deployment.yaml file, and I'm going to run it. So it says like, okay, the deployment is created. Now what do is let's quickly go and say like kubectl and get deployment. So see like what is the status of our particular deployment. So let me do a clear screen and then let me show you. So let us go and let us again type kubectl get deployment. So now we are seeing that one deployment is ready, right? Let's go and check the pod, like whether the pod is ready or not. So basically a deployment, what it does is it creates a pods, and we are checking the pod is ready and telling like one pod is running. So basically the Flask application that is deployed in a container, and what we did is we pulled that container and we deployed it in Kubernetes now, and it is up and running. Let's quickly go to the screen and let's see like basically we are seeing one cluster. you can see this workload, and we are seeing, okay, there is one deployment that is there and it's in okay status. In case if there is any failure when deploying, or failure, or there is a problem with the image, you can see over here that it's in failed status, right? I will show you like how to go and debug it. And the services is okay. We are not created the service now. Let me go to the service, but before that, let me show how we can get more details about the pod. So this is the pod name, whatever name you are seeing over here, this is the pod name. So what I'm going to do is I'm going to do an kubectl describe pod, and then basically I'm going to give the pod name over here. This will show you the pod status, what are all the steps that were involved, and whether if there is any failure in between, then you will get to know the failure. This is one thing. Let me clear the screen. There is another one command called kubectl, which will show the entire log the container is created, right? So basically you can type for kubectl logs and then the container name. And if you see, this is the final log that you get, and you are seeing here basically the gunicorn has started. It's listening in port 8080. That's the port we are given in deployment.yaml, and that's a default port as well. And there have been some issues over here. If you see here, it says could not load dynamic library. It's looking for TensorRT. We don't have GPUs over here, right? So basically all this has failed, and what it has done is it has rolled back to the CPU version, because we don't have GPU assigned to this particular container. We have only CPU. If you go here, you can see what is assigned to that particular container. So it's only one vCPU. It has failed, but it has still started and allocated the CPU for it. Now you can also schedule a GPU, schedule a Kubernetes service on top of a GPU. So you can assign quota of a GPU. You can just bring in the compute instance of GPU, but in this case, I'm going to use CPU. And within the Flask API, I have printed like model and vocabulary loaded, and you can see basically the message getting printed over here. So that means our Flask application is up and running, and the models have been loaded and kept in memory and ready for serving. Now, before using this one, what we have to do is we have to also create something called service. And what I told you is service is basically enabling network access to a set of pods. Now, with the deployment is enough. I can even check with deployment, but when I have multiple pods, it becomes not so manageable. In this case, I have only one pod. If you see over here, I have only one pod, and that's the number of instances I have given in my deployment.yaml. So I have only one pod here, but you can also schedule multiple pods if you want. If you want to load balance your traffic because against multiple pods, you can do that as well. I will show that to you in the next video, where I will talk about scaling the Kubernetes pod and doing A/B deployment and all. But for now, it's only one pod. But I'm going to go and create the service for it, and the service was in service.yaml file. So if you see over here, there is a service.yaml file which I showed you earlier. I'm going to do an kubectl, the same command what I did for deployment, -f, I apply -f service.yaml, and then now the services is created for this. Now what we can do is we can do a kubectl get services. So it will show you what is the services. Now you can see over here, the second one is that is the SA classifier, and we are given a load balancer. We are telling to use the cloud provided load balancer, and this is the cluster IP address. This is nothing but the internal IP address. But for me to access this service from an external world, I need the external IP address, and it's in pending status. That means the service is still getting created. You can see pending status over here. Now let me go back to the Kubernetes screen and see if the services is created. Now you can basically see the services. You can see the services now. The name is SA classifier, and there's a creating service endpoint. It's still in progress. So let's wait for some time. Yeah, now it is created, and it has assigned an external IP address, that is 35.227.128.24. And you can see, if you refresh the screen also, you can see the service would have created now over here. So what we are going to do is, now the service is created. Now the service is created and saying OK status and load balancer. Now basically what I'm going to do is, I am going to go over here and just a minute. Let me open the Cloud Shell again, because I refreshed the screen. So in order to start the Cloud Shell, I'm going to say activate Cloud Shell again, and I'm going to expand it to a new screen. right? Now this particular the cloud shell is loading, but the app is deployed now. So what am I going to do is I'm going to again say go and get the external IP address. kubectl gets services, which will give me the external IP address about this particular port. And what I'm going to do is I'm going to go and call the flask API now and see whether the flask API is working. And for that, what I'm going to do is I'm going to basically call the health check service. If you remember, the health check service is one that we had created to see whether the service, whether the flask service is up or not. So this, and the to call it, I'm going to use slash health check. And you can see basically the flask, it's called the health check service, and the health check service has written output as I am good, right? And if you go back and you can, if you want to check the code of the health check service, yeah, I'm going to the flask app API, the flask final, and if you see on the health check, that's what I'm printing. So I'm returning I am good. So that means the flask is up and running, it's in pretty much healthy status. Now let's go and run our sentiment classifier. And again, I'm going to use the same IP address, but for this the URL is going to be SA classifier, right? That's what we had given to call SC classifier. That's what we had given to call this particular flask app. So now what I'm going to do is I'm just going to copy paste. I just already stored it in my notepad because I have to type a lot. So what I'm doing is I am calling the SC classifier endpoint. And if you see, like the SC classifier endpoint is over here in the flask app, I'm calling this endpoint, which will return me the sentiment score of this particular text, right? And what I'm doing is I'm passing this text value. I'm just telling you, working on my way through it, but definitely changes your view of investment. Wish it was available on Audible. And the sentiment seems to be a positive sentiment. And I'm also telling the content type is application JSON because I'm pasting it, I'm sending a JSON object. Now, if you don't want to send the content type every time, you can go to the Flask app and set it over there so that it always accepts for a JSON format. But I'm sending the JSON format, and let me send it now. And it returns, basically, if you see over, it returns a prediction value which is 0.87. That is it's in the higher end of the positive side, and the sentiment is positive as well. So that's about it. What we have done is we have taken the Flask app that we created, and then we containerized the Flask app. We pushed it to an Docker repository. It can be a Docker hub as well, but in this case I pushed it to a Google container registry. And then what we have done is we have deployed that particular container. We defined a deployment.yaml file and service.yaml file, which are nothing but Kubernetes descriptor files. And we deployed that using a container. And then we created an endpoint. And based on that, we are just calling and getting an inference back. So you have a Flask application deployed for serving. Now, in the next video, we will see how we can scale this particular service. Sometimes the traffic may be pretty high and you want to scale the service, how you can scale it. And we will see like some other features of Kubernetes. Thank you.